Hello friends, welcome once again to ASOMNOF Online Maths. In this video, I will continue with my works on the Chord Theorem, and I want to solve one more problems on the Chord Theorem before I go into another theorems, okay? Do not forget that this video is proudly powered by Your Lesson app. Catch me on their TikTok page at Your Lesson app. Go to Play Store, download and subscribe to their app so that you can enjoy my math videos. So this problem is telling us that two chords of length 10 cm and 24 cm respectively lie on opposite sides of a circle. If the radius of the circle is 13 cm, calculate the distance between the two chords. Now let us draw the circle and insert the chords. This is the circle and these are the chords. This is the first one and this is the second one. We are told that their distances are, let me draw very well, let this be the second one, and here is the center of the circle. We are told from this problem that they lie on opposite sides. You can see that they are facing each other, and we are asked to get the distance between the two chords. Here is the distance between the two chords, which I've made in red. Remember that you are free to draw let's say a straight line here from this point to this point, so that from this particular point down to this point is a radius, and the radius of the circle we are told is 13 cm. So here is 13 because radius move from center to circumference, and also here we also be 13 cm because distance from the center to the circumference again is a radius. You can still repeat the same thing here, because if you do the same thing, here we also be 13 cm and here we be 13 cm because they are the radius. And remember that any line from the center to a chord is always perpendicular to the chord. Okay? Then we are told that the lengths of the chords are 10 cm and 24 cm. So the one that is 10 cm should be this one that is shorter. So if this is 10 cm, it means that here should be 5 and here should be 5. Because according to the theorem, this line in red bisects the chord. And this one, which is 24 centimeters, if you divide by 2, here will be 12 and here will also be 12. So our target is to get the distance between the two chords. And how do we get the distance between the two chords? To get the distance, you need to get here A, you need to get A and B. So the sum of A and B will give us the required length. So let us work it out. Let us bring the smaller triangle on top, this triangle like this. Let us bring it out. Here is 13, here is 5, and this is our right angle, and here is A. So let us get the value of A from Pythagoras theorem. So A squared is the same thing as 13 squared, take away 5 squared. And of course, 13 squared is 169 minus 5 squared, which will give us 25. 169 minus 25 is 144. And this A, if A squared is equal to 144, that means A is equal to square root of 144, right? And the square root of 144 is the same thing as 12 centimeters, okay? It will give us 12 centimeters. So if A is 12 centimeters, let us leave it and look for the value of B. To get the value of B, we need to bring out this particular triangle here, down there. This particular triangle, I'm just highlighting this one here. Our B is already, this is B, we need it. Here is 12 and here is 13. So from Pythagoras theorem again, you have that B squared is equal to 13 squared, take away 12 squared. So 13 squared is 169, 12 squared is 144, and when you subtract, you are getting 25. So that B becomes the square root of 25, and of course, the square root of 25 will give us 5 centimeters. And the distance between the two chords is the sum of A and B. That's the distance. So distance between the two chords will be A plus B. And already A is 12 centimeters, while B is 5 centimeters. And when you add 12 and 5 together, you are getting 17 centimeters.
This is just the distance between the two chords. Do not forget that this video is proudly powered by Your Lesson app. Catch me on their TikTok page at Your Lesson app. Go to Play Store, download and subscribe to their app so that you can enjoy my math videos. Thank you for viewing and may God bless you. Bye bye.